Hello, everyone. My name is Andres, and I'm here with Soren. We are part of QB's data consultancy company, and we have experience migrating Airflow and deploying Airflow at scale. Recently, we've been playing a little bit between the intersection of AI agents and Airflow, and we're here to show you some of the things that we have built. So this is going to be the agenda of today. Let me go a little bit quickly. First, we're going to show our problem space, which is going to be a common problem that Airflow users face. Second is going to be our proposed solution. Then a quick demo of this application. Then we're going to explain a little bit some of the key lessons that we learned. And finally, how you can extend this application to your own tech stack so you can develop and make things a little bit more complicated and tailored to your own needs. And of course, at the end, we're going to have a room for questions. So even with powerful orchestrations like Airflow, or orchestrations tool like Airflow, keeping pipelines healthy still takes a surprising amount of engineering time. First, it can take a long time, even hours, to figure it out that your pipelines are failing, that a downstream dependency is slowing things down, or an upstream change are breaking things down the line. Then it comes to fixing. Fixing also takes time. And until you fix that issue, your reports, your data products, your dashboard are going to stay delayed. And finally, prevention, which can be the hardest part because you have to put a good amount of time into developing the right frameworks for testing or using the good monitoring tools to stop the same issues keep happening on your workflows. The good thing is that Airflow already has all the data that you need to tackle these problems. But right now, only humans can connect the dots. But what if we can change that? What if an AI agent could do that heavy lifting for us? It can find opportunities by analyzing Airflow data, like Airflow logs, Airflow config files, Airflow DAGs, past historical runs, and it can uncover failures for you. It can identify bottlenecks or risky patterns. It can fix issues faster by pinpointing the real root cause of the problem and suggesting a fix for that problem, or even applying the fix if you're gonna go for a more automated way. So no longer your teams keep waiting for your solution. And most importantly, and what we envision, it's to have an AI agent that can handle that pipeline maintenance while data engineers focus on building more features. So this is going to be a small diagram of the agent that we created. The flow starts with a user asking a prompt and telling to the agent to analyze the log files, to scan the log files and analyze the log files. Then we're going to have the agent. At the core of the agent, we're going to have the main LLM, which is going to act like the brain of the agent. It's going to give the agent the ability to reason, to understand through requests, and to adapt its actions to reach a desired goal. Then the agent it's built on LangGraph. And the way that you can think of LangGraph, it's a framework to build agents kind of like in a graph-based. It helps the agent to coordinate with tools. It gives the agent enough context to the LLM about the tools that it can use, and also helps them kind of like makes an execution graph of the task that it's going to do so it can reach that goal. It's going to create kind of like a DAG, but you should think that this DAG is somehow dynamic. It's going to change based on the outputs of the tools. And finally, we have the LangGraph MCP client. And you can think this like the connection layer, just like in Airflow, where you're going to set up your connections for your MCP servers. For this occasion, we are only using two MCPs. One is going to be the Airflow MCP, and the other one is going to be GitHub MCP. The MCPs are just basically the ones doing the actions. We also have like some Python custom functions that are going to help us to do that extra functionality that we need. So to discuss the details of this architecture, Soren is going to continue. He was the main developer and architecture of this.
Thank you, Andres. So we have an example scenario that every data engineer has experienced. Some upstream data source has changed in format and it's broken your pipeline, and problems are cascading through your organization. You're getting emails and Slacks from stakeholders, and you're thrashing just trying to analyze what the problem has. So I've been in this situation dozens of times. On one situation kind of motivated where we went with this project and stands out in my mind. It was at eBay 15 years ago. And we had this ETL process. It actually paid merchants for advertising on their sites. And it ran every 15 minutes. So when this thing went down, which it did probably once a week, every 2 weeks, sometimes twice a week, some upstream developer at the website level changing the XML format. And finally, the project owner was so frustrated with this, he went to the guy who wrote the ETL tool, one of the most brilliant people I've ever worked with, like, Denny, this is your tool. Don't you have something that just fixes it? And Denny kind of replied, well, yeah, I got that right here on my laptop. And of course, 15 years ago, we didn't have that. No, that he was just lying, teasing. But now, that might be on my laptop. So the agentic solution that we have is to go out, check logs, accept prompts, and even do some analysis and even some code change to try to modify and prepare for a review. And we have a quick demo. So the demo begins with the agent already running. It's loaded various tools from various MCP servers. We've loaded tools for Airflow, Git, and Snowflake, and these tools have shared with the agent its ability to interface with the APIs of these applications. At the bottom of the screen, you can see a user has prompted the agent to diagnose the issues and to fix them if possible. After some time, the agent has completed its analysis. It's analyzed the DAGs, the source code, and the logs, and it's found that there was an error in one of the logs, that some invalid identifier called created@, which is a column in a SQL query, caused this error. It's also found that this column is, because of the error, is in a specific DAG, and it's found that there's also another column in there called update@. And it's also found that this table, this target table, is referenced in a semantic layer in SQL, semantic.sql and YAML.sql. And it's proposed some fixes. It proposes changing the DDL of the table, adding these two columns. It's proposed a modification to the DAG as well. And it's also recommended changing the semantic layer in which this target table is used. It's also found some deprecations that we don't have any control of, and recommends cleaning up the code. It prompts us if we would like to proceed with the recommended fixes. We acknowledge it, yes. We are prompted for our passcode so that we can authenticate to GitHub. And a few moments later, it will create a branch, change some code in 3 files, and create a PR for that merge, and give you the link to where it can be found. Jumping to the Airflow GitHub UI, we can observe these changes and approve them, reject them, modify them, or just completely ignore them. But at least we kind of have a lead where the error was and what files are involved. So, brief recap, we've loaded some tools. We've asked the agent to do some analysis. The agent has done its analysis, prompted us to authorize to proceed, and then made some changes in GitHub where we can review them. So it wouldn't be LLMs without some prompt engineering. Some of the best practices to working with these agents is to just ask them what tools are loaded. They work best if the prompt has the tool name and even some parameters that you're looking for. Something as simple as get DAG info, DAG ID equals. Of course, the reliability improves by some of the underlying system prompts that the agent bootstraps the LLM with. When I was messing with this, I got answers about how to fix my HVAC system when I asked about Airflow rather than Apache Airflow, turn the trigger there. And the LLMs have varying support for tools, so the prompt engineering can get quite complex depending on which LLM is underlying the agent. And here's some of the research that we've done so far. The bigger remote LLMs work best. The smaller ones haven't really been trained to deal with tools. And by that, it's the tools return these JSON contexts that the LLM must interpret. And we have found that, depending on the size of the LLM, there's the thinking, which is the ability to make a plan, and what we call complexity, which is the ability to use multiple tools to come up with a multi-step plan to solve the problem. So the challenges, well, there's many LLMs, there's many MCP servers out there, there's actually many agent frameworks, and finding the right combination to work with can be quite challenging. We found that the agent that we're using now is kind of limited to struggles with loading lots of tools. And when we mean tools, these are functions on top of REST endpoints. So you're given an endpoint plus all the methods that you might use to access, whether it be a push or a get or a patch. We had some problems with the MCP servers. For instance, Slack and Airflow, there is no official MCP server. So we had to evaluate some of the MCP servers that are out there in the wild and that are just labors of love. And all of them are pre V.1 releases, so documentation is very challenging, and adoption isn't there to get a lot of help online either. The LLMs, especially the remote ones, can struggle with token rates. The tokens to bootstrap LLM with the right context can get quite lengthy. The developer that did this one has kind of laid out this whole process. The first analyze the logs, then analyze the DAGs. If that has to iterate with the remote model, you hit the token limit really quickly. Solution to that would be to use a local model. The local models don't work so well. They haven't been trained on to use tools, or their memory footprint's too large. I think the DeepSeek one was like 450 gig. And with that, I'm going to hand it back to Andres.
So what you just saw, it was just a simple agent using a small amount of tools, a small amount of basically all the things that you're using right now if you are running Airflow. But you can do things a little bit more complicated, or things that just not wait on the clock or just don't wait for a prompt if you add more things from your stack. So this is an example. We can have a Snowflake event table that is logging all the changes from your schemas. Then you can have an Airflow DAG that is using a SQL sensor or a Snowflake sensor, basically an SQL sensor that checks the count of how many times that event that you're looking for, it's happening. If that count is greater than 0, you can query that table, get the payload, and then then trigger an agent task. And that agent task is going to be similar from the demo, but now you're going to have more information, more context, because you know already what changed. So with a little bit of prompt engineering, and especially what do you want to fix? Do you want to fix code? Do you want to fix your semantic layers, your YAML files? You can work more with this prompt engineer, with this prompt, add that context, and then you can tell the agent to analyze the data, find the root cause, and suggest fixes. That suggestion part can be through Slack or some channel of communication. Then the MCPs are going to do the actions, going to apply the fixes, update the code, make PR, or notify. You also have the option to do like event-driven scheduling or something that reacts to an event. But here you will need like a metadata tool, things like DataHub. DataHub can send a metadata change event, use that event to send to a AWS SQS event bus, trigger that with a DAG, and basically have the same flow. The important thing in this doesn't have to be scheduled with Airflow, but you can schedule it with a Lambda function or something like that. But also with Airflow is possible. Just keep in mind that you have to think in how many changes are you getting. If you're getting a lot of changes, then your environment's going to have a lot of workers from your pool. It's going to trigger a lot of calls to your LLM, so you might have a lot of costs. So you have to think on how to scale these, and depends on how many changes you get. That's pretty much it. So a quick recap. Even with Airflow, keeping pipelines still takes a large amount of time. So what we envision and what we're trying to solve is to have an AI agent that can handle that maintenance, that pipeline maintenance. You saw this on the demo. We saw the agent analyze Airflow error logs and automatically propose and implement fixes. And the key thing is that you can build these kind of solutions right now with Airflow. You can experiment. And also you can tailor the solution to your own needs. And we are in Qubis, we would love to help you if you want to do something like this.